amplifier. So the next type what we are going to see is class AB. So class AB amplifier is also one type of amplifier which will overcome this problem of crossover distortion. So push-pull complementary symmetry will also overcome this problem, but this class AB amplifier will also ensure that the problem of crossover distortion is completely absent in class B amplifiers. Okay, so see, class A, you know, it will conduct for the entire cycle. So I can say it is 100% class A will conduct for the entire duration of your signal. And class B, you know, it is 50%. So when I say class AB, it is going to conduct somewhere between 50% and 100%. So the transistor will conduct between 50% and 100%. It will not conduct fully. It will not conduct less than half of the input cycle. So somewhere between 50 and 100%, the transistor will conduct. So I am going to use, you can see I am going to use the two NPN transistors and the emitters resistance are connected, and I'm going to use one transformer at the input side. I'm going to use one transformer at the output side. So that might make your circuit look bulky, but if you remove these transformers, circuit is very, very simple. So you see, you give VCC here, and that VCC is given to the center type of transformer, and you have emitter resistance RE in both the transistors Q1 and Q2, and you have additional biasing resistors R1 and R2. See, the values of R1, R2, and RE, what you choose, it is going to determine how much percentage your transistor is going to conduct. So it is going to be dependent on whatever resistance values you are going to take. Okay, so the values of R1, R2, and RE will determine what is the conducting percentage of your transistor. Okay, so the diagram is shown here. It is also a class AB push pull. So whenever you have two transistors with emitters connected, you call it as push amplifier. Meaning of push pull is when one transistor is pushed into conduction, the other transistor is pulled out of conduction, which means that when Q1 is on, Q2 will be off. When Q1 is off, Q2 will be on. So that is the meaning of push pull configuration. Okay. So the circuit is going to be exactly same as class B amplifier. So if you compare this diagram with the class B amplifier, you will find no change except that I'm going to add two resistance RE at the emitter of both the transistors for stability. So in the while studying about biasing circuits, we have seen if I'm going to add RE, it is going to increase the stability of my circuit. But what is the drawback of adding RE to your circuit? See, if I add RE, my stability is improving a lot. That is a big plus point for me. But what is the drawback of adding RE in any circuit? Can anybody say? What is the drawback of having RE, emitter resistance? Please at least guess the answer. Don't remain silent. Say something. We'll discuss whether it is correct or not. Not an issue. What is the effect of adding RE to any circuit?
Power is
I am not able to get.
Reduced gain.
In the form of how will the gain get reduced? You're almost correct. You are saying it indirectly. Gain is reduced because of what? Any resistance will have what? Any resistance will have
Current.
no. Any resistance you will have this component associated with resistance always. When current flows through resistance, what will happen? When current flows through resistance, what will happen?
power dissipation.
Power dissipation, that is what I was expecting. When power dissipation happens, gain will be reduced, efficiency will be reduced, bandwidth will be reduced, everything will be coming down. But one important thing, what is your plus point is my circuit is becoming more and more stable because of adding RE. So adding RE also, you cannot just like that add any value. You should add a value of RE such that the power dissipation is going to be minimum. Only when RE equal to 0, power dissipation will be 0. But RE equal to 0, put a stability will not achieved, right? So you will definitely put a minimal value of RE for which stability is also not compromised the gain and other parameters are also not compromised. So I am adding 3 resistance here, R1, R2, Re, to bias my transistor slightly towards class A operation. See, since it is class AB, the operating point will lie between A and B. You know, for class A amplifier, the operating point is exactly in the middle. For class A, if you can remember this diagram, the operating point is exactly in the middle. This is your class A. And for class B, it is exactly on the x-axis. Because one transistor is always in cutoff. So where will be the operating point for class B? It will be somewhere between A and B. That is what they are saying. The Q point will be slightly moving towards class A. So the Q point is in between A and B. So this is the Q point for class AB. Okay, it will be somewhere in between the Q points of A and B. So I can say the transistor is not perfectly conducting for 100%, but and it is not conducting only 50%. It is between 50 and 100%. My transistor is going to conduct. And how I am choosing this Q point between A and B? By the choice of resistance R1, R2, and Re in my circuit. Okay, by proper choice of the resistance R1, R2, and Re, I am ensuring that the Q point is between the Q point of class A and class B,